Hello, this is Michael White. This is the 7th grade science textbook. We're in Chapter 2, Lesson 2, Mathematics and Science. My Planet Diary. People all over the world can use math in their everyday lives. Here are some examples. Let's say you went to a furniture store. You see a couch you like, and it's priced at $1,150, on sale for 40% off. What do? You take 0.40 times 1,150 and subtract that answer from the original price. In the kitchen, recipes tell you certain amounts of ingredients, so you use a measuring cup. People also use math while they're playing board games, such as rolling dice or playing with cards. Math might not be appealing to some people, but they do need to acknowledge that it can be very important in their daily lives. What math skills do scientists use? From measuring to collecting data, scientists use math every day. Math skills that scientists use to collect data include estimation, accuracy, and precision, and significant figures. Estimation. An estimate is an approximation of a number based on reasonable assumptions. An estimate is not a guess. It is always based on known information. Scientists often rely on estimates when they cannot obtain exact numbers. Their estimates might be based on indirect measurements, calculations, and models. For example, they may estimate the distance between stars based on indirect measurements because they can't measure the distance directly. Other estimates might be based on a sample. Accuracy and precision. People often use the words accuracy and precision to describe the same idea. In science, these words have different meanings. Accuracy refers to how close a measurement is to the true or accepted value. Precision refers to how close a group of measurements are to each other. How can you be sure that a measurement is both accurate and precise? First, use a high-quality measurement tool. Second, measure carefully. Finally, repeat the measurement a few times. If your measurement is the same each time, you can assume that it is reliable. A reliable measurement is both accurate and precise. Look at Figure 1. What math tools do scientists use? Mathematics is just as powerful a tool for analyzing data as it is for collecting it. Scientists use certain math tools to analyze data. These tools include calculating percent error, finding the mean, median, mode, and range, and checking the reasonableness of data, percent error. Often, scientists must make measurements that already have accepted values. For example, an accepted or true value for the density of the metal copper is 8.92 grams per cubic centimeter. Suppose you measure the mass and volume of a sample of the metal copper and calculate a density of 9.37 grams per cubic centimeter. You know your calculation is not accurate, but by how much? Percent error calculations are a way to determine how accurate an experimental value is. A low percent error means that the result you obtained was accurate. A high percent error means that your result was not accurate. It may not be accurate because you did not measure carefully or something was wrong with your measurement tool. Mean, median, mode, and range. Walking along a beach one night, you see a sea turtle laying her eggs in the sand. You start to wonder about the sea turtle nest. What is the average number of eggs in a nest? What is the range of eggs in a group of nests? Scientists ask questions like these too. Their answers come from analyzing data. Use Figure 3 to analyze sea turtle egg data yourself. Mean. The mean is the numerical average of a set of data. To find the mean, add up the numbers in the data set. Then divide the sum by the total number of items you added. Find the mean for the egg data. Median. The median is the middle number in a set of data. To find the median, list all the numbers in order from least to greatest. The median is the middle entry. If a list has an even number of entries, add the two middle numbers together and divide by 2 to find the median. Mode. The mode is the number that appears most often in a list of numbers. Range. The range of a set of data is the difference between the greatest value and the least value in the set. Reasonable and anomalous data. An important part of analyzing any set of data is to ask, Are these data reasonable? Do they make sense? For example, suppose a scientist who studies sea turtles measures the ocean water temperature each night for 5 nights. His data for the first 4 nights are 26 degrees Celsius, 23 degrees Celsius, 25 degrees Celsius, and 24 degrees Celsius. On the last night, he asks a student to make the measurement. The student records 81 in the data book. Are the data reasonable? The reading on day 5 is very different. Some variation in ocean temperature makes sense within a small range, but it doesn't make sense for ocean temperatures to rise 57 degrees in one day, from 24 to 81. The 81 degrees Celsius does not fit with the rest of the data. Data that do not fit with the rest of the data set are called anomalous data. In this case, the anomalous data are explainable. The student measured in degrees Fahrenheit instead of degrees Celsius. Sometimes asking whether data are reasonable can uncover sources of error or unknown variables. Investigating the reason for anomalous data can lead to new discoveries.